Good evening, friend. Study with Apala, Parvin Singh book. Chapter 2nd, The Earth. Final pictures. So the final picture of the internal structure of the earth as developed from the study of the seismic waves records on the earthquakes divides it into three well defined cells or zones or spheres: the crust, the mantle, and the core. In each of these cells there are records of significant variations on the basis of which each cell can be further subdivided into different layers with definite characteristics. Following is only an outlines of major zones and cells of which the earth is believed to be made up. The crust. It is the uppermost cell of the earth that extends to variables depth below the mountains, 75 km, continents 35 km, and ocean 5 km. The Morovicic discontinuity mark the lower boundary of the crust. Study of seismic quakes reveals following details about thickness of the crust. Mountains areas under the Himalayas, the crust is believed to be 70 to 75 km thick. Under the Hindu Kush mountain, it is 60 km thick, and under the Ants, 75 km thick. Continental areas, the thickness of the crust is a continent varies from 30 to 40 km. Along the continental slopes, the thickness of the crust shows considerable variations. Oceanic areas, the crust over below the oceanic water varies in thickness from some maximums of 19 km to low values of 5 km in deep oceans. The continental crust is further distinguished into three layers: A, B, and C. A A or the upper layer is between 2 to 10 km thick, and it is of low density, 2.2 G plus CC. It is mostly made up of sedimentary rocks. In this layers, the P waves velocities range from 1.8 to 5.0 km per second. The B or the middle layers of the continental crust is relatively dense, 2.4 to 2.6 gram per cc, and seismic waves attains velocity of to 5 to 6.2 km per second. This layer is also sometimes called the granite layer and is made up mostly of granites, gneisses, and other related igneous and metamorphic rocks. At a places it acquires a thickness of 20 km or more. In fact, at many places in the world, it is the B layers of the crust which is exposed on the surface because the overlying A layer has already been removed due to prolonged erosions by weathering agents. Since granite layers is mostly made up of silicates of aluminum and potassium, it is also sometimes referred as a Cl means silica, Si silica, and Al alumina. Layers whilst discussing the internal structure of the earth. The sea layer is the lowermost layer of the continental crust and has a density of 2.8 to 3.3 G per cc, in which P waves attains as a high velocity as 6 to 7.6 km per second. This layer is also referred as a basaltic layer of the crust and acquires a thickness of 25 to 40 km under the continent. It is made predominantly of basic minerals rich in magnesium silicate, and hence is sometimes named as SEMA, silica for silica, and Ma for magnesiums. The oceanic crust, it is generally the extension of a sea layer of the continental crust that make the top layer of the oceans. Is most oceans A and B layers being practically absent from there. The oceanic crust is estimated to have a value of 2.54 into 10 to the power 9 cc with an average density of 3.00 g per cc and figure 2.7 a in figure. Don't forget to make a diagrams with the best labeling. So structure of the earth not to scale: A sedimentary layers, B granitic layers Cl, and C basaltic layers Cm. 35 kilometers seames and moho and mantles and moho seam layer silica's crust mountains metamorphic continental crust here indicate the this metamorphic rock formed mountain sedimentary formations oceanic crust. The mantles. It is the second concentric cell of the earth that lies beneath the crust everywhere. These zones starting from the lower boundary of the crust continue up to a depth of 2900 km. The exact nature of the mantle is as yet incompletely understood. It has been subdivided into an upper and lower mantles, the boundary between the two layers being placed at 900 to 1000 km below the earth. The upper mantle is further divided into two layers of 400 and 600 km thickness respectively. Enough seismic data is available to suggest that density is the mantle rises from 3.3 gram per cc from just below the crust to about 5.7 g per cc at the base of the mantles. Recent studies indicate that a part of the upper mantles from 100 km to 500 km depth it is in a plastic rather than solid state. This zone has been named as asthenospheres, Greek asthenes without strength. It is believed to be the source of much velocities activity of volcanic activity of the earth and many other processes. The asthenosphere is believed to be located entirely in the upper mantle and supports supports the slowly moving techniques plates. Thank you. Like, support and subscribe this channel. Thank you.